Hello and welcome to the Coastal Resilience Decision Support System. Utilizing ESRI's ArcGIS API for JavaScript platform, this web mapping tool has a modular plugin architecture, allowing for apps to be developed around specific coastal issues. These apps explore risk and vulnerability and help identify nature-based solutions. In this video, we will demonstrate the Coastal Defense app. Coastal Defense is an app that examines how natural habitats can help protect coastal areas by reducing the amount of wave energy hitting the shore. It was developed through a collaboration led by the Nature Conservancy between scientists, engineers, planners, and tool developers. The app runs a model that is part of Natural Capital's Invest suite of tools. The app uses standard engineering techniques to help users estimate how and where to restore or conserve critical habitat to reduce wave impacts and increase the resilience of a coastal community. Presence of submerged coastal habitats decreases the water depth and forces oncoming waves to break before they would otherwise. This results in smaller and less energetic waves shoreward of the habitat. In this way, coastal habitats can help protect shorelines by acting as natural breakwaters. The app calculates offshore wave height and period by combining the fetch distance, the average water depth in the area of interest, and the wind speed that is selected by the user. Coastal Defense provides reasonable estimates of the beneficial role that coastal habitats play in protecting shorelines. The app simplifies wave propagation and assumes that waves evolve in a one-dimensional plane. The app contains a geoprocessing service that allows users to interactively identify a particular point of interest and get instant results for how habitats can attenuate waves. The app addresses one of United Nations' essentials for making cities resilient. Specifically, the app helps to 1. Identify areas that may be at risk of coastal erosion and inundation from wave action and storm surge. 2. Examine the role of coastal habitats in attenuating wave height and energy. And 3. Determine appropriate adaptation strategies that incorporate green and gray infrastructure trade-offs. The Coastal Defense app is intended to identify solutions by exploring how coastal habitats can attenuate waves. In Puget Sound, Washington, the first version of this app was developed to address concerns of farmers in the diking district, who wanted to evaluate the role that existing marshes play in reducing risk to levee infrastructure. We can use the Coastal Defense app to explore this. Here we see Skagit Bay in Puget Sound. We can select which units we want outputs in. Then we click on a spot within the bay, and the tool locates the nearest transect indicated by the yellow dots on the shoreline. A cross-section of that transect appears in the input panel, where the orange line is the elevation, the red line indicates a levee present, and the green is the current extent of the marsh. You can then simulate different physical and biological conditions by selecting a wave and wind condition from several options that have been locally calibrated. Let's choose maximum. We can also select the water and storm surge levels. To simulate a future marsh condition, we can move the sliders to make the marsh bigger or smaller to see what impact that has on wave attenuation. Now we can run our scenario. Coastal Defense generates two output graphs. The wave height graph shows the reduction in wave height for three scenarios: current, future, and absence of all habitat. The light green background represents the extent of your current marsh, and the dark green is the future marsh. The wave reduction graph shows the percent of total wave reduction due to the presence of the marsh. The app also estimates the probability of the levee overtopping under the scenario we selected, and calculates the amount of additional levee height that would be necessary to prevent overtopping. Now let's look at a different version of Coastal Defense in the Gulf. Here, the Coastal Defense app evaluates the wave height and energy reduction provided by another valuable coastal habitat, oyster reefs. Let's zoom in to Mobile Bay, Alabama. You can see that there's already an app open called the Restoration Explorer. This is an app that allows users to map areas that are suitable for oyster reef restoration, based on ecological and socioeconomic criteria that are important to them. Other apps and suitability layers like this can help determine general areas where we might want to run the Coastal Defense tool. Using our suitability layer as a reference, let's zoom into an area of interest. Now we can activate the Coastal Defense app. Click on a spot on the map, and the tool locates the nearest transect. The user interface then appears. and we can begin to design an oyster reef restoration project and examine its potential wave attenuation benefits. The first step is to select the units we want our wave attenuation outputs to be measured in. Let's stick with meters. Next, we can select the physical conditions of the wave that will be modeled. Let's start with wind type. The drop-down menu provides various wind intensities that have been calibrated with local measurements. Each one is further defined in the instructions panel on the left. Let's select maximum. We can also select what the water level is when the wave occurs. Again, the drop-down reveals several tidal levels from local benchmarks. Let's select mean, higher, high water. Next, we can choose the structure of the reef we hope to build by either selecting from common reef types like trapezoid or dome, or by entering specific structural measurements. Lastly, we can use the slider bar to change the distance the reef is located from the shore. Notice, as we adjust it, the graphic on the map moves dynamically as well. Once we've settled on an offshore location, we can run our scenario. Just like the Marsh version, the app generates two output graphs. The wave height graph shows the wave height under the current scenario with no habitat and under the oyster reef restoration scenario. As the output text states, under the wave conditions we selected, our reef could potentially reduce wave height by 85.5%. The wave reduction graph shows that the presence of our oyster reef reduced wave power by 94%. The Puget Sound and Mobile Bay applications represent proof-of-concept sites, whereas in South Florida, the Coastal Defense app has evolved to an enterprise level. Here, the Invest Coastal Protection model is contained within an ARC toolbox, which includes all wind and wave parameters, including sea level rise and storm surge, all coastal habitats, and the built infrastructure for exploring hybrid green-gray solutions. The ARC toolbox can now be deployed at various scales and can be customized to expose specific parameters to meet decision support needs. Enterprising Coastal Defense allows us to customize the interface in South Florida into storylines, so users can easily understand the purpose of the app in supporting restoration, adaptation, and conservation decisions. The first storyline is to demonstrate how existing coral reefs provide coastal protection now. Here, Coastal Defense quantifies how coral reefs protect coastal areas by reducing nearshore wave height, currents, and water level. This information supports decisions regarding the resilience of coastal communities to storms. The second story is to understand how communities can maintain and restore the state's coral reefs for coastal protection now and in the future. Coastal Defense quantifies how these wave attenuation and erosion reduction services may be compromised due to rising seas and reef degradation. With active management and reef restoration, the resilience of the coastline to the impacts of sea level rise can be improved. Stakeholders are also very interested in how natural and artificial underwater structures can work together. The app quantifies how restored coral reefs together with engineered structures can reduce nearshore wave height and currents, water level, or inundation during storms. And finally, Coastal Defense demonstrates how multiple habitats like coral reefs and mangrove forests can reduce wave height, water level, and loss of fine sediments in nearshore regions. The Coastal Resilience Tool platform and Coastal Defense app help make complex social ecological models more accessible to non-technical audiences. Coastal Defense gives stakeholders the power to make more informed decisions. It also provides a mechanism to change perceptions of what defenses can be, and help make a more compelling case for the role of nature. ArcGIS for Server and the ESRI JavaScript API has provided the full package of solutions for highlighting the intuitive design, performance, and usability of the Coastal Defense app. This has led to important opportunities, including being the first environmental partner for the Rockefeller Foundation's 100 Resilient Cities initiative, providing technical support on natural infrastructure. Decisions makers are looking for cost-effective risk reduction solutions. Coastal Defense provides a direct way to help communities understand their vulnerability, reduce their risk, and determine the value of nature-based solutions. To further explore the app, visit maps.coastalresilience.org.